Hello everyone, I am Marcela Falcão. I lead growth at Cubo. We are the largest hub of tech innovation in Latin America, and today I have the huge pleasure to host a podcast about navigating technology trends and their real impact, and Forward, an event offered by Oxygia Ventures. I am here with two amazing guests, so Ben Evans and Julia De Luca, and for us to kick off, I would like to ask for a brief presentation for each one of you, please. Julia, can you start?
Sure. So I've been with Itaú BBA now for around 6.5 years, in finance for around 15. I'm currently part of the investment banking team covering technology, also responsible for the coverage of global growth funds and venture capital funds. Also a writer for NASDAQ Global and MIT Tech Review, and I'm very happy to be here.
Yeah, so I'm Benedict Evans. I've done various things. I was originally a sell-side equity analyst covering mobile operators and worked in consulting and strategy for a while in venture capital, and I've been an independent analyst for 5 or 6 years now.
Amazing. So today the idea is for us to explore a bit more on top of AI. So your iconic presentation since 2013, you're doing them. So I would like to hear more about why are your thoughts about AI eating the world?
Well, that's a kind of a very broad question. So, I mean, look, so large language models really started working a bit over 2 years ago when OpenAI launched ChatGPT 3.5. And it kind of quickly became clear that this was sort of the major trend in the tech industry. And this is what everyone is interested in. This is what everyone is trying to build companies around, build products around. Now, that said, all the other stuff that was still going on before is still there. So e-commerce is still growing, cloud and SaaS and enterprise software and e-commerce and digital advertising, and all of those trends are still there. But smartphones sort of had been the center of the tech industry, and it kind of happened. And before that, it was the web, and before that, it was PCs. And so now there's a kind of a general feeling that this is the kind of the mega trend, the thing that everyone gets built around over the next 10 or 15 years. However, after that, no one really knows what that means. So it's not clear at the most kind of fundamental level how much longer these models will keep getting better. This is the scaling question. It's really not clear what they're best used for. We've got some early use cases, but it's not clear like how to think about what they're for and how you use them. And it's not clear how you build products and companies around them. There's a bunch of opinions on what that might look like, but we don't really have the answers yet.
And on top of a comparative view, like how do you analyze it with the mobile revolution or even with the internet revolution?
So, I mean, the tech industry tends to move in platform shifts. And so every sort of 10 or 15 years, there's a sort of new central paradigm. And that's what all the investment in innovation and company creation happens in. And so from sort of the mid-60s through to the late 70s, it was mainframes, which was dominated by IBM. And then from the late 70s through to the mid-90s, it was the PC, which was then Microsoft and Intel. And then from the mid-90s through to sort of the late 2010s, it was the web. And then it was smartphones from, say, 2010 for the last sort of 15 years. Smartphones have happened now. Something over 5 billion people have one. The new iPhone is not radically different to the one before. Like the innovation rate, we've kind of done it. We've got that now. All the white space has been filled in. And so for the last few years, people have been thinking, well, what would the next platform shift be? Would there be one? What would that look like? What would that mean? And so people talked about crypto and VR and a bunch of other things. And it's kind of pretty clear now that large language models are a profoundly important breakthrough in what you can get computers to do. And that's what everyone is going to be building companies around for the next 5, 10, 15 years. Now, there's another view that says that if these models scale another 2, 3 orders of magnitude, then they might be much more than that. So the base case is to say, well, this is one of these platform shifts that you have every 10 or 15 years. So this will be like the iPhone or cloud or SaaS or the web or the PC. There's a more aggressive view that says, no, this is more like computing. It's like a fundamental change in what we can automate. And so the consequences will be larger than mobile or the web or PCs. At the moment, we don't really know. And we don't have any way of forecasting that because we don't have an underlying theoretical model of why LLMs work so well and what would happen if you were to scale them 10 or 100 times. We don't even know if we can, but we certainly don't know what would happen if we did. And so we don't know what it is that this will be able to do on a 3 to 5 year view.
And regarding this point, you explore a lot on your presentation the difference between awareness and usage, especially in 2024. What are your thoughts about it, this potential of like more people using it? What is the big shift that we have to take in the industry?
Well, so it's an observation I made at the beginning of the presentation is that everybody has heard of this and a very large number of people have tried it. And that's partly because you're sort of standing on the shoulders of giants. So we're using all of the infrastructure that got built in the last 25 years. And so you don't need to wait for telcos to build broadband networks and consumers to buy PCs or consumers to buy smartphones or people to build 5G, 3G, 4G, 5G networks. You don't need to wait for data centers and all the software and all the infrastructure to get built. All that infrastructure is kind of there. And so as a consumer, all you need to do to try ChatGPT is just go to the website.
Yeah.
It's not like you needed to decide, right, I'm going to spend $1,000 and go out and buy a smartphone and then wait for people to build stuff for it. So it's much easier for people to try it. However, most people who've tried ChatGPT haven't been back. Something between sort of 40 and 60% of people in most of the developed world have tried this, but only sort of 1, 2, 3, 4% have turned into daily active users. And then there's an argument. So some of that is that the models aren't good enough yet, and they'll get better. Some of it is that you need to it will take time for people to change their habits. It takes time for enterprise software to get built and big companies to move their workflows over to new technologies. It doesn't just happen overnight. And some of it is also a debate as to whether a chatbot is really the right user experience or the right interface, in that it's something that looks like a greater level of abstraction, a much easier way to use computers, a general purpose way to use a computer, because you don't need to know what to ask. You don't need somebody to have built a tool. You can just ask it to do things. But on the other hand, there's many things you can ask it that it can't do. And it's not clear what those would be. And it's not clear what it is that you could use this for. And so there's a few early use cases where it's kind of clear and obvious that you can use it for this, which is mainly software development and marketing. And there's a few other things that kind of spread thinly horizontally across many verticals, like, drafting certain kind of emails, certain kinds of brainstorming, certain kinds of suggestion. But there's a lot of things that a lot of people do every day where it's not clear how you would use this, or even if you could use this, or that you might maybe need a lot of tools to be built on top. And so there's a very kind of live debate as to what that's going to look like over the next couple of years.
Perfect. Julia, shifting a bit to Latin America, like what you've seen in the latest years and top industries that we have the usage of AI here in our region.
I think that the first point is that these large language models, they demand a lot of capital. So obviously they're all being built mainly in the US through capex from the big tech companies. And so here in Latin America, we're not seeing large language models being built, but yet applications on top of these models, right? So we call them AI enabled. When we look at the technology sector, last year in 2023, around $1 billion USD went directly to what we call AI enabled companies. And just as an order of magnitude, there was around $3 billion invested in Latin America. So it was like it's a good chunk. When we look at the specific verticals and specific industries, I agree with Benedict that it's still very early to tell what will happen specifically, right? But we're seeing certain use cases that are very relevant. So, for example, when we look at Mercado Libre, both on the finance side and on the retail side, they're using their AI models to have a better sense of how much they can give in credit for their marketplace holders, right? And on the retail side, obviously they are streamlining logistics and operations. So this is a clear use case. I think in Itaú, in the bank, we're also using AI to personalize the interaction of everyone with their respective software app of the bank. So I think it's a very relevant use case as well. But still, I think that looking at Latin America, we should see even more use in agriculture, since we are a power in this front. We have the case of certain companies such as Bayer already using artificial intelligence in the crop fields, but I think we're going to see a lot more in the upcoming years.
Yeah, and I agree also on top of the awareness issue that we have here in the local tech ecosystem. As we see at Skubu, we had only 30% of our startups using, even though in the application layer. So we're incentivizing a lot of awareness initiatives, partnering up with the big tech companies. I figure out that's a good way so we can increase this adoption in the long term. I figure out that we are still in the awareness point of the game here in the region.
I agree.
A bit more on top of the business of AI in the end of the day. So scaling it, we know it has a lot of cloud dependency. And today we have only 30% of the workflows in cloud. How do you see this adoption of AI evolving in perspective with this scope that we see cloud for most of the people that are in tech? We figure out that's a thing that's already in the long term, and for mostly people think that everybody already adopted. But when you see this 30% number, I believe it scares a lot.
So this is a CIO survey that says sort of 25 to 30% of enterprise workflows are in the cloud now, and that's after 25 years of people talking about cloud and building cloud systems. And of course, you can't just kind of presume that, of course, cloud is better. It kind of depends. If you're running a big bank, like maybe you've got your mainframes and they work, and why would you spend a lot of money to move to a different platform when you've got other priorities? So it takes time to build new systems, to deploy new technology. And, as I think we said a moment ago, like none of this was working 2 years ago. It takes 2 years to build an enterprise software, and it takes 2 years for a big company to think about whether it's going to buy it. And then it takes another 2 years for them to deploy it. So, and if you think about something like CrowdStrike, or you think about the fact that, when you open your bank's app, it works. It always works every single time. And when you go to the ATM, it always has your money and it always gets it right every single time. There's kind of big important reasons why big companies don't like to deploy quick software in a hurry. They like to take their time and be kind of slow and careful and methodical. And in a sense, many of the questions around generative AI, the answer is, well, it'll work like all the other platform shifts. So how did you decide where to deploy this first? How did you decide what budget to come out of? How do you think about which departments you should use it for? How did you think about the right use cases? Which vendors did you choose? Did you go with Microsoft or Google or with Accenture? Did you pay Accenture to build something, or IBM? Or did you buy something off the shelf from a startup? Well, those kinds of questions come up every single time how did you build your smartphone app? How did you build your wealth management platform? How did you build anything? Well, it depends, and it's complicated, and it takes a while to work it out. And I think that applies exactly the same way to this. The challenge in this case, that makes it slightly different, is firstly that the nature of it is changing. So if you were thinking about smartphones in 2007 or 2010 or 2010, you knew that they would get better and cheaper, and you maybe weren't sure whether BlackBerry would survive, but you kind of knew what you were dealing with. You weren't saying, well, maybe in a couple of years, your smartphone might be able to unfold and fill the whole wall. Or maybe it might have like retinal projection, or maybe it might be able to read your mind. You kind of knew what you were dealing with in principle. You just knew it would get a bit better and a bit faster. We're not really in that situation yet with large language models, because it may be, as I said a while ago, if these things get scale 100x or 1000x, and we don't know whether that will happen or not, then what we're looking at now will be pretty radically different from the capabilities that we'll have in 3 or 5 years' time. So that's kind of one puzzle, is it's still all kind of changing quite a lot in ways that were not really true of, say, the web or smartphones. I think the second question is that it was kind of not clear. I'm just saying, maybe this is a kind of a useful comparison to think about the web, that you go back and look at the web in like 93, 94, 95, even 96. it wasn't clear that the internet would really only be the web, that everything else would get subsumed into the web. There were all these other systems, not just, there were proprietary networks. So there was Airwell and CompuServe and services like that. They were quite separate from the web. And there was Gopher and FTP and proprietary things like Pointcast. And so it was not clear that it would all be the web. Then Tim Berners-Lee's original web browser had an editor. So the idea was you would go to the web page and you could edit it, because he thought this was kind of like a network drive and it was a document sharing system. It wasn't clear that, no, this was a publishing system. I remember I started as a student in 1995 and I installed a bunch of web browsers on my PC, and some of them had web servers as well. So the thinking was that, well, you'll turn your PC on and then you'll share documents from your PC with other people. They'll only be able to read them as long as your PC's turned on. So like individual people sitting at their desks in an office would each be running a web server as a way of sharing documents with their colleagues. And this sounds kind of bizarre now, but it was just not clear at the time what the web was or how it would work, and like what the kind of the moving parts would be, and where the levers and the points of leverage and the kind of the choke points were going to be. And meanwhile, of course, and this is kind of a classic pattern for, if you think about Clay Christensen's idea of disruption, that generally the new thing is bad at the things that matter to the old thing. So the first compute PCs in the late 70s, if you were running operations at a big bank and you said, well, can I replace the computers in our data center with a bunch of Apple IIs? Of course not. They couldn't possibly do that. They didn't have anything like that kind of scaling or reliability or efficiency, but they did something else. And the same thing with the web in the mid-90s. Could you replace your mainframes or your broadcast television system with the web? Of course not. But it did something else. Could you replace Excel or Photoshop and build those in the web? Of course not. It took kind of 10 years for Google Docs to start working, and it took 20 years, maybe longer, before you could put Photoshop in a web browser. But meanwhile, the web was useful for a bunch of other things. And the reason I say this is like, it's not, if you use these things now and you say, well, can it do complicated maths? Or can I use it to do very specific data analysis or data retrieval? You'll find the answer is no, not really. It will look like it is. It will make something that looks like an answer and get it wrong. But that's kind of the wrong question to ask. Instead, you kind of have to ask, well, what are the new things that you can do with this that you couldn't do before? And we're still kind of trying to work out the answer to that, which makes it quite difficult as a company to think, well, there's some early and obvious things you can do with this. So everyone always talks about software development. You can automate your call center. You can automate some customer support. You can automatically summarize all the reviews on your e-commerce site. Great. That's probably not what we're going to be talking about in 5 years' time.
That's fantastic. And the thing that you mentioned, that 30 years ago, it wasn't clear about what the web was going to do. And suddenly when this content creation Sherry thing popped out, it was the big thing. How long did it take? So it started in 1995, 1993, 4, and it was clear up to 2000s or not?
Well, so different things become clearer over time. So people were talking about, and of course, consumer behavior shifts as well. This is the point about, the ChatGPT gets to a couple of 100 million users in a couple of months because everyone's on the internet. There were only 20 or 30 million consumer PCs on Earth in 94 or 95. On the entire planet, there were 20 or 30 million consumer PCs. There's maybe 100 million PCs in total, but most of them are in big companies. So there's tens of millions of people in the entire planet who have a PC. And none of them have a modem. And could even connect to the internet. So it was very, very small. I remember I found an interview with Bill Gates from 1984 when the IBM PC was launched. And he said, it was a big project. We put 35 people on it out of our 100 staff. So Microsoft had 100 people in the whole company with 100 people. And they put 35 people on to work on the IBM
in
1984.
PC.
1984, yeah. So we forget, and meanwhile, to sort of go back a little bit further, the killer use case for the original PCs, which of course predate what we now call a PC, so things like the Apple II. So the killer use case for the Apple II was VisiCalc, which was the first software spreadsheet. And we don't know that no one knows this now, but like before that, there were actually paper spreadsheets. You would buy a pad. You can still buy them on Amazon. You buy a pad of spreadsheet paper, and then maybe you'd have a calculator, or you'd have a notepad, and you'd do the sums by hand, and then you'd fill in the cells one by one on the piece of paper. And then if someone said, well, what happens if the interest rate goes up 0.5%? Well, then you just have to do it all again. Like cell by cell by cell all the way through. And so the guy called Dan Bricklin, I forget the other co-founder's name, he doing an MBA, and he saw people doing spreadsheets on a blackboard, and he thought, well, you could do that on a computer. And so he made a software spreadsheet on an Apple II, and he would show it to accountants, and they would like lose their minds looking at this, because like you change the interest rate here and all the other numbers change. And you say this now and people think, yes. But at the time, like, you could do like a week of work in 10 minutes. And so this was absolutely mind-blowing. On the other hand, if you were a lawyer and you looked at that, you thought, well, that's great, and my accountant should see this. But I don't do spreadsheets, so what am I supposed to do with this? Which I think is a way a lot of people feel using ChatGPT. Like, that's very clever, but I don't do that. What am I supposed to do with this? The same thing with the internet. Like, it was not clear that it was like what the platform levels would be. It was not clear, like, and which is a kind of a question now. Is ChatGPT the thing, or will ChatGPT be an API call, and there'll be lots of other people who build apps on top? What kind of apps could you build in a web browser? No one was really thinking you could build like a spreadsheet or inside a web browser, and you needed a lot of other technology needed to happen before that became possible. When Mark Benioff was going around saying like you could put a CRM in a web page, and it could run on my computers, and then you wouldn't have to deploy it on your computers. And so then if I've got a new version, that's not a year of planning for you to deploy it into your data centers. I can just add the new version and all your staff have it that afternoon. All of those kinds of, like, today it's just really hard to think about, like, what did that mean? It's like if you just sort of remember what it was like trying to socialize before you had a mobile phone. Like, so all of your friends would agree we're going to meet at this bar at this time. And if you got to the bar and they'd already left, well, then you just went home. Like, try telling this to a 10 or 15-year-old today. They're like, what are you talking about? Like, well, I guess I'm just not going to talk to my friends today then. I'll go home. And maybe someone will call me on the I'll go to a payphone, and maybe I'll call someone's mother on a payphone, and maybe their mother will tell me where they will, like, it's like the world, and so this was all of this kind of had to happen, and now we don't see it. And that's sort of where we are now with LLMs. Is this a web browser, or is this like an underlying technology that gets used to use a bunch of other stuff on top of it? What will this look like?
Yeah, this is a very, very interesting thing, because we are in between of scaling consumer adoption, and I wanted to explore a bit on top of the investor's perspective, because I believe that VC also plays a role in this game. So Julia, if you could explore a bit of what you're seeing on all this money that's going to AI, and specifically in Latin America, and what should be the bets that we are seeing on the best deals in the market?
I think that globally, several VCs are already saying that they only invest if the company has an AI angle. For example, Point72, a very known fintech and financial infrastructure investors, moved their thesis to being only AI companies, right? And when we talk to Andreessen, for example, Andreessen Horowitz, they are also looking at, of course, they still look at like B2B softwares, etc., but it has to have an AI component that's very relevant. The same for SoftBank, for example, which is an active guy here in Latin America. When we look at LATAM, I think it's very known and a common knowledge that we're not going to have these large language models here in the region being developed here, but AI enabled solutions for sure. So a recent deal that, for example, Nubank bought Hyperplane was a case of artificial intelligence in the venture world, and a big acquirer acting upon it. And we are seeing companies that are trying to to change their model. For example, Pipe 5 from Alessio, they were a workflow solution. With AI, they changed completely, right? So I think that venture capitalists from the US, they are ahead in a sense that they are already seeing what's happening there and are already directing their thesis towards the theme. When we look at the local investors, of course, they want to see an angle of AI, but they know that we're not going to have like the big companies based in, or at least starting in Brazil or Latin America. First, because there's a lot of capital needed. Second, because of talent, right? So we still have a very big problem in talent in the technology ecosystem, and this is spread out in education finally. So I think that when we look at Latin America, we have still a big challenge, but we are also seeing cool cases happen, and venture capitalists are very important because in a scenario where the government does not invest that much in technology, they play a big role in investing in these companies and making sure that we are evolving.
I think just picking up on some of those points, I mean, it's important to point out that like most American VCs aren't investing in foundation models either. Like the typical venture capital fund, even in the US, has got a $100, $200, $300 million fund and writes maybe double-digit million checks, but does not write $500 million checks. And so there was a sort of a period, certainly last year, well into this year, where you're either Andreessen Horowitz or Coatue or someone, and you can write a $500 million check to Anthropic. Bearing in mind, most of the foundation models aren't even available for investment on that level. So you can't invest in Google at that level. You can't invest directly in Llama. You can't invest directly even in OpenAI, really. And so you've got as it might be. And meanwhile, so you've got that kind of space of people building foundation models. And then you've got everybody else. So there was this phrase this time last year where people would talk about thin GPT wrappers. Meaning like you've built like a thin layer on top of the OpenAI APIs, and you've built some buttons in a website, but all you're actually doing is passing a prompt and some data back to ChatGPT and getting an answer back. And it was kind of tough to see how you could build a defensible company there, partly because like you weren't actually using any technology yourself, so anyone else could build the same thing, and secondly because ChatGPT might just do that. And so they kind of the need for the basic product was both indefensible from competition, but it might just get swallowed up as the foundation model got better. I think that concern has sort of receded somewhat, kind of for two reasons. I think firstly, really in the last year, or arguably in the last 18 months, it's become very clear that there's going to be a whole bunch of foundation models of various shapes and sizes. So, I mean, the last penny to drop was Amazon launching its Nova models last week. And so now it's really only Microsoft that doesn't have its own models. They haven't still using OpenAI's models. So there's going to be sort of between half a dozen and a dozen organizations that have a bunch of foundation models. Secondly, each of them have like the best model, which is the most expensive, and the model that's sort of almost as good, like 90% as good, but 5% of the price. And then there's a foundation, then there's a model you can squeeze onto the edge. Can you get a model onto a smartphone, onto a PC, at which point it's free, at least free for the developer, because it's the users paying for the compute. So you're going to have like a dozen or 2 dozen models out there. So you're not that quite so worried about what OpenAI might do. But on the other side, if you are now we've kind of got to the point where people say, well, hang on a second, we don't look at a normal enterprise SaaS company and say, well, that's just an AWS wrapper. Every software company runs on AWS or GCP or Azure. And we don't say, well, they're just a GCP wrapper. Because what you do is you build product, user interface, user experience, tooling, auditing, data control, workflow, route to market, sales, support. You build everything else on top of that. And yes, maybe the underlying compute or data storage or image recognition is happening on AWS, but that's not what the product is. And so this is part of this sense of like, if you work at a big company, you don't just like, take away all the software and give everyone ChatGPT and say, there you are, just go off and do your work. You've got, a big bank, you have your compliance department, and the compliance department has 30 different software tools.
We actually can't use it in the bank.
Well, that's a separate one, is you're not allowed to. But even if you were allowed to, you can't just replace Salesforce with ChatGPT.
Yeah.
You might use ChatGPT to suggest things to say in Salesforce, but you still need all of those deterministic systems, the data and the workflow and the tooling and the process. And it might be that you get a whole new wave of stuff that gets automated away and you have fewer tools. But right now, the typical big company has 400 or 500 SaaS apps. And so we're at this moment where people are thinking, right, so what are the 1,000 LLM-powered SaaS apps? And how do you invest in those?
So, double-clicking on the profitability of this market.
Sorry, can we update that to double tapping?
Double tapping on the profitability of this market and the VC-backed company versus the Magnificent Seven. Where do you believe that the liquidity will come from?
Well, the sort of funny thing about venture is there's a bunch of paradoxes in venture. You're supposed to be the most optimistic person there is, and you're the only person an entrepreneur will ever meet whose actual job is to believe that this is going to work. And yet you say no to 95% of people. It's like your whole job is to believe that that's going to work, but actually you say no to 99% of the people that you meet. And one of the other paradox, which is I'm thinking of in response to your question, is that you think of startups as being these things that happen incredibly quickly. And yet venture returns come slower than any other investment field, almost any other investment field. I don't know, maybe investing in cement companies or something takes longer. But you write the check and then you find out, then you get your money 5 to 7 years later. You kind of know if it didn't work quite quickly. The ones that don't work, that tends to become clear sooner. But the ones that work, you start getting your returns in for the ones that work 6, 7, 8, 9, 10, 12 years after you wrote the first check. So, and in a sense, the ones where you get an early result are the ones where you're unhappy. So, if something gets bought for 10x your money after 2 years as a VC, generally you'll be pretty unhappy because you would prefer that they'd have hung on and made it 50x, because that's how your fund profile works. So it's very early, it's far too early really to have VCs really getting liquidity from any of this stuff. And the liquidity you'll probably be pretty upset about.
Yeah. So VC still unclear. Exploring a bit more on top of workforce. So you mentioned on your presentation that AI gives you infinite interns. How do you see that AI is already reshaping the job market?
Well, in a sense, all conversations about generative AI seem to become like a hunt for metaphors, that's one of my metaphors. So their interns is talking, well, it's like mobile, or it's like this, or it's like that, or it's like PCs. It's like having lots of interns. And I think the valuable thing in the reason I think that's kind of a useful metaphor is imagine you had 1,000 interns. Well, there's a bunch of stuff that you could get them to do for you. That would be really useful, but it might take you quite a while to think of what you might get them to do. And then it would be quite hard for you to explain to them what you wanted them to do. And then you'd have to check the work. And it would be really useful in principle if you could have 100 interns to work for you, but you couldn't just get them to do it for you and go home. And so you'd have to have quite a lot of thought about that. I mean, one of the ways I used to use this was to think imagine you're running a call center. You would like to know every single call where the customer sounds suspicious and every single call where the service agent is rude. And you don't need an expert for that. You could get a 10-year-old to do that. You could probably get a dog to do that. One of my colleagues at A16Z liked to say that AI will do anything you could train a dog to do, which is useful as well because you can never be completely sure what you trained the dog to do. For the sake, the dog is probably doing what you told it to do, but that may not be what you think you told it to do. You might have told it something slightly different from what you wanted and you didn't realize, which is the problem of training bias. And so you've kind of got this sense of, but part of the point of that is the the analogy is you can automate things that computers could never automate before. So there's a kind of a broad class of thing that was very easy for people to do, but very hard for us to explain to a machine. So it's very easy for you to tell a computer how you calculate a mortgage. It's very hard for you to do it in your head a million times. But it's very easy to tell a computer how you calculate a mortgage. You just write down the steps and you put it in a mainframe in 1978 and you press go and it just does it for you. But it's very hard for you to say, why is that credit card transaction weird? It's very easy for you to look at it and go, yeah, that's weird. But it's very hard for you to explain why, or explain why that's a picture of a cat. You think it's easy. And then you start writing down steps of how you tell it's a cat and not a dog. And 15 years later, it still doesn't work. It works most of the time, but it doesn't actually work. And so what machine learning did was let you automate this broad class of stuff that you could never explain to computers. Because instead of explaining it, you turn it into a statistics problem. And now large language models are kind of doing the same again. They let us automate a broad class of thing that you could never really explain to a computer before. But now you can tell it to do this thing. The catch is, it's a statistical probabilistic system. It's not a deterministic system because they're not really deterministic questions. So it might be wrong. And it might be quite hard to work out how you would tell it to do the question. It might come back and generally it will give you an answer that looks like a good answer. And there are some questions where looks like a good answer is what you want. And the other questions where looks like a good answer is absolutely not what you want. So, I don't know, give me a good draft for an introduction to this podcast. Well, there isn't really a wrong answer to that. And if it's made some mistakes, you'd be able to see it. Please calculate the tax liability if I inherit an apartment in Sao Paulo from my parents and then I sell it and gift half of it to my brother and also move to Rio, Yeah, ChatGPT will give you something that looks like an answer, but you probably want to talk to a tax lawyer to make sure that it actually is the right answer, because that could be quite an important mistake.
Yes.
So the challenge is trying to work out, well, what are those kinds of questions? And how do you present that as a product? Do you give it to the user and they work it out? Well, that works for some things. Or do you abstract it away in an API call and surround it in tooling and process and pre-processing and post-processing and filtering so that you can control that and manage that, and the user doesn't think they're getting the right answer, or it doesn't necessarily give the answer to the user exactly. You're using it as part of a flow where you understand what the right questions are and how to ask the question and how to deal with an answer. So it's one of the slides in my presentation is how do we deal? Well, we make the models better. Easy. Okay, of course. We'll make the models 1,000,000 times better, and then nobody will have to work again. Right. Okay. Meanwhile, thank you. Meanwhile, what do we do now with what we have now? And the answers are sort of, you either look for things where there is no wrong answer or where the mistakes are easy to see. Or you think about ways that you can abstract this away, make it an API call, wrap it in much more product and tooling and interface so that you manage those questions.
And Julia, with this whole bunch of interns that we managed to see right now and that Benedict explored, and doubling down on the lack of talent that you mentioned in Latin America, how does this all fits in to our culture, to our needs, and to our workforce here in the reality of Brazil specifically?
I think it's early to tell, in a sense that I don't know the numbers, but if the usage versus awareness of ChatGPT in developed economies is low, I would say that in Brazil is much, much, much lower, right? So I think that, of course, we're fortunate enough to know all of this and know English, which is also an important step in the region and an important barrier. And our companies are already looking at the theme and trying to implement in our daily basis. But I think it's very early to see or to say how it's going to impact the Brazilian population in general, because I think it would be very obnoxious to say that what we have here is the Brazilian population, right? Mm-hmm. So but to answer your question, I think that we are already seeing uses in the big companies, but not that spread out across the organization. So in specific areas or specific teams, and we are also seeing in education a couple of schools, high-end schools, already using a bit of it in the day-to-day. But I think it's very early to see how artificial intelligence will impact Brazil as a country. So I as I mentioned in my first answer, I think that agriculture is a big one. So we are by far a strength in agriculture, and I think that there are a lot of uses that can be applied to this sector, making it more productivity enhanced, not being that harmful to the ecosystem and nature in general. So I think that there are several things that can and will happen, but it's still very early to tell.
Just picking up on one thing you said, there are these sort of two approaches to try and say at a very deterministic level, what will this mean? And one of them is a sort of a top-down model that says, well, let's look for places where you've got low labor productivity, where there's lots of things that you might be able to automate with machine learning. And so you say, well, obviously, this is always the joke, is you get your children a job as a plumber, because that's the thing that will never get automated. Whereas, being an investment banker, that will be really easy to automate. Of course, the reality over the last 30 years is that isn't what happened. But the other, so you can try and do it very top down and say which industries have lots of people doing lots of really boring grunt work, sitting at a computer, telling the computer stuff that the computer should be able to do for them. And the other way, the problem with that is you could have done that in 1995 and you would have predicted for the internet. And you'd have got some things right, but you'd have missed a lot of things that happened as well. But the other way you can do this, which is what I wanted to picking up on what you said, is you can kind of go bottom up and you can say, well, what does it mean that creating video is going to be radically cheaper and easier? What does it mean that synthesizing and summarizing information is going to be radically simpler and easier? What does it mean that translation is going to work now? So one view on what this means, sort of a language question here, is that places like the Philippines, where you have arbitrage between high-income English-speaking countries and low-income English-speaking countries, meaning there's this huge business in call centers and customer support, that industry is very worried because they think, well, now all that customer support will get automated. But there's another view that says, yes, but what about all the language pairs where you didn't have a high-income and a low-income country that spoke the same language? What if you want to do customer support for Finnish people? Like, there is nobody on earth who speaks Finnish. And even in Finland, half the people speak Swedish. Like, there's nobody in a low-income country that speaks Finnish or Norwegian, or Korean. So what happens if now you can do the customer support for South Koreans in Egypt? And there's nobody on earth who speaks Egyptian and South. There's like one person who speaks Egyptian and South, Arabic and South and Korean. But now the translation will work. Or certainly the first layer of translation will work. And so, you were talking about speaking English. Well, what does it mean for all the Brazilians who don't speak English that now the internet will sort of be in Portuguese? That now that won't matter in anything like as much as it matters today.
Still, the models need to be trained a lot in Portuguese, so it's very interesting if you know both languages. In ChatGPT, for example, like an answer in English is much better than an answer in Portuguese, probably because these models are working on available data, and there's more available data in English rather than in Portuguese.
But that's definitely an issue, but there's two slightly different things there. It produces the answer, so you can get it to produce a Portuguese answer or an English answer. And the English answer will be better because there's way more English text in the model. But then you could take the English answer and translate
it to Portuguese.
And that would be a different thing, and that would probably give you a better result.
Use a tipo. Well, approaching to the end of the podcast, I wanted to close with a glance of the future. So, Benedict, if you can share a bit of how should we prepare for it since we're so early in the game, and what are your thoughts of this collaboration between human and AI should be?
I don't know. I mean, I mentioned earlier about things about mobile, and how mobile changed our lives, and now we kind of forget it. And the same thing with spreadsheets. Now we kind of forget that. I mean, the joke I always used to make here is that young people won't believe this, but before spreadsheets, investment banking associates worked really long hours. And now, thanks to Excel, Goldman Sachs associates can get their work done by lunchtime on Friday and go home for the weekend.
That's true, Julia.
Yeah, that's your experience.
Not always.
And of course, that's not what happened. What happened is when it became much cheaper and easier to do that analysis, you did way more analysis and you had way more analysts. You have way more accountants. The US number of accountants in the US has gone up in the last 30 years consistently, even as you would think computers would let you automate what they're doing. But the other side of this is like the kind of classic thing that people always talk about, the one job that's disappeared from automation is the elevator attendant. And so elevators before the Second World War, you can think of them as like public transport. They're like a privately owned streetcar. They're a tram that runs up and down instead of horizontally, but they're basically a tram. And there's a driver. There's a man or a woman standing there with an accelerator and a brake, and if they screw up, they can kill you. And they have to like judge the speed to slow down to get to each floor. And they look at who's most important in the elevator and decide which floor to go to first. So theoretically, if you're really junior and you worked in a tall office building, you might get into the elevator and be stuck there for an hour because the driver might take more important people to their floors first. And then you get automatic elevators in 1950, and you just get in and you press the button. And to begin with, you still have the attendant, and the attendant gets in and you say floor 5, please, and they press button 5. But if I did the last slide in my presentation is a chart of elevator attendants employed in the USA, and it's a perfect bell curve. It does this. And today, when you get into an elevator, you don't say, I'm going to use an automatic elevator now, or indeed an AI elevator, because it's got like there's a computer dispatching and deciding which. It's an AI elevator. It's using AI. But we don't say that. We just say I got the lift. And the same thing now, like maybe a more recent example, like there was this classic XKCD cartoon from 10, 11, 12 years ago, which is an engineering cartoon. And the boss goes to the engineer and says, I want every photograph to say if it's taken in a national park. And the engineer says, latitude, longitude, look up, I'll match against a database. I can do that this afternoon. And then the boss says, also, it should flag if the picture contains a bird. And the engineer says, okay, I'll need a research group in 5 years. And today, no, that's just an API call. But we forget that, like, no, that just works now. You take a picture of your dog or your child on your phone, and your phone you can find that picture again. And so what I'm sort of saying is that maybe this thing will scale 1 million times and it will rule the world and nobody will have to work again, or it'll just kill us, or it'll treat us as pets. That's probably it'll treat us as pets. But the most likely scenario is that in 10 years' time, like, yeah, of course my phone can rewrite my emails for me. That's just what computers do. Of course the computer can do that. So it's just software. And so there's this classic quote from 1970 from this researcher called Larry Tesler. He said, intelligence is whatever machines can't do yet. Because once machines do it, then, well, that's not intelligence, that's just software. And so I think like the base prediction is like, I can't tell you what people are going to do with this any more than we could have been sitting here in 2000 and predicted Uber or Tinder. I can tell you that the most likely outcome is that in 10 years' time, we won't notice it anymore. It'll just become stuff that was always there.
Fantastic. Julia, closing remarks?
No, after this, I don't know what I'm going to say.
I monologued.
No, but I think it's very interesting, the point of realizing that you are, like the elevator example is great. Like it is a machine that's working, but you don't think about it because it's so natural in your day-to-day life. Anyways, I think that's exciting. I'm at least very excited to see what's going to happen. So let's see.
There was a moment like 10 years ago where people started talking about smartphones as giving you superpowers. So I press a button here and a taxi appears. Like magic. Like...
That's a good way to put it.
I press a button and half an hour later, my dinner arrives.
Yes.
It's like it's magic.
Yeah.
And how quickly we became accustomed to this and we don't see it anymore.
Yeah. So thank you so much for your time, Benedict. Thank you, Julia. It was amazing to
Thank
have this
you.
chat and learn more about how AI is reshaping our world.